welcome to Defin episode number 68. Our
Fuck,
first...
hold on. I wanted him on 69.
Well, we can have him on 69 as well.
God damn it. Okay.
Finally, we're reaching the bottom of the barrel for jokes now. Like completely juvenile humor.
Oh, yeah.
We lost all sophistication, and then it's all downhill from here.
When you say we lost all sophistication...
That's a bold assumption.
Can you remind me
claim.
when in the previous episodes we had found all the sophistication?
Before we started Defin.
Yeah, maybe it was the last time Michiel was on, you know.
Maybe.
All
Anyway,
downhill
so
from there.
Yeah.
episode number 69 minus 1.
I'll tell
Off
David
by
Nolan
one.
that one, Michiel.
Off by one.
Off by one, exactly.
It's
So
a
welcome to
classic
Defin,
era.
Michiel. I would say welcome back to Defin,
Yes.
Michiel. So it's been some time, and we are very happy to have you back. So let's get started. So what is happening with Clojure World? I think the plan is that Ray is going to continue for half an hour now, right? Ranting and bullshitting. So we can just sit back and enjoy our tea.
What? No, I'm not going to do anything about that. Yeah, I think we did have a few little chit chats about what's going on with Spec and Mali and things like this, and these other things that are popping out from the woodwork. But other than that, I don't know. I don't think it's particularly relevant for Michiel, that's for sure. Or is it, Michiel?
Well, I am still waiting for Spec 2 to come out. So in that sense, it's relevant, I guess. But I think I'm not unique in that regard.
Yeah, I have a feeling that it's a bit like, you know, I don't know what's going on with the sort of, it's a bit like, I don't know, there's some sort of big brain occurring. You know, Rich is in his hammock thinking about shit, and we just got to wait until he just like lets out some big fart or something, or, you know, just gradually kind of explodes the functional universe with Spec 2. But I think a lot of people have given up because it's just been so long now, you know.
How long was it anyway? Is it like 6 years? Or 5 years or more?
Yeah, 6 years, I think.
Yeah, and I think I think that is not so bad. It's just, I think it's been 2 or 3 years since he said, I got it wrong. You know, oops.
Yeah. Well, I think we were both at Clojure 2019, Ray, you and me.
Yeah.
And then Alex, he had a talk about, well, we're working on Spec 2, and hopefully it will come out at the end of the year. So everyone was like, "Oh, cool."
Well, that was in 2019, though, wasn't it?
Yeah. And I think in the last episode you described this as the Osborne effect or?
Yeah,
I don't know if it was me, but like someone might have
pre-announcing.
What was the laptop that didn't sell?
Yes, it's the Augusta Spawn. Yeah,
Osborne. Yeah. So I think I'm seeing that effect clearly in the ecosystem, at least among several people.
But the effect of that one was that they pre-announced that the next version would be better. And then the whole thing went bankrupt. So are you saying that Spec is going to become bankrupt like the Osborne computers?
Well, not bankrupt, but everyone is waiting for Spec 2, and not really a lot is happening around Spec 1 because of that reason, because that is my impression. I want to add Clojure Spec to Babeshka, scripting tool, but I'm not doing it right now because I'm waiting for Spec 2. And the author of Reframe, Mike Thompson, he also said, I want to add something to Reframe for validation, but I'm not sure if he wasn't sure if we should wait for Spec 2, and Mali looked great for this purpose to him. So yeah, I think we're in this transition period where nobody's sure what to do about spec anymore.
Yeah. Yeah, but I think it's not like, Rich owes us
No,
spec
no,
too. So I think if
no, of course
community
not.
decides that, okay, we're all happy with Mali or schema, whatever, something
Yeah,
that was there before, and then the new things now, and then if there is a critical mass around the new
Well, hang
tool,
on,
then
VJ.
that's
I
what
mean,
it's going to
I
be.
disagree with you there because I
Hmm.
think he actually does owe us because it's been announced, it's happening. So I think this idea that he doesn't owe us something is a bit off. I think no. I think there
No,
has been
it's
it's in the process of being fixed. There is a sort of branch there. There is a
yeah,
yeah, but there is no commitment, right? It's open source, so you do it when you want to do it, and it's not like a marketing deadline for anything.
yeah.
So
You could wonder if
well,
it would have been better if they just didn't announce it and then announced it when it was really ready, like part of Clojure
yeah, yeah,
1.11 or something.
yeah,
And then everybody maybe would have invested more into spec as it
yeah.
is right now.
but I think it's
But
like
I'm
you
That's a
were
not
fair
sure.
saying,
point.
though, Michiel, is that and I think the fundamental point that everyone's known for a long time is that it has a chilling effect on the ecosystem. Whenever you I think it had a chilling effect on the ecosystem just being in alpha to begin with, and it stayed in alpha forever. So everyone's thinking, it's going to change. It's obviously
Yeah.
why is it not, and why is it in alpha for so long? So it must there.
It's a lot of hammock time. So coming out with the details on Spec 2 takes longer than the entire design of Clojure itself. So,
Yeah.
but if it's worth the
Yeah.
wait, yeah, maybe it's very good. We'll just have to see, right?
Yeah, but I definitely think that in the meantime, it's like I think the guys at Matosin have just took a practical perspective, which is okay. Let's just start doing some things with the tech that's out there right now. So I really like the Mali approach. I've started using it. I'm not giving up on spec because I think spec is still very good for things for certain data interchange.
Yeah, definitely. I'm using spec for parsing code as well. I have made a tool to search code through Clojure specs, so you can describe the shape of the code, and that works very well with spec. I haven't tried this with Mali because Mali didn't have this sequence schemas yet before 030.
Right.
So, but spec works very very well for these kinds of things. So maybe in the end, the community will see in like 3 years from now when to choose Mali and when to choose spec, and what are the benefits of both approaches.
Yeah. The only thing that's a bit annoying, obviously, is having to learn two tools that are kind of different enough to be, to be a bit annoying, So
Yeah. I proposed to Tommy, let's make a tool that helps you migrate from spec to Mali schemas and vice versa. I think that would be cool.
Yeah, that would be really cool. Yeah.
And then I think every project requires 3 dependencies now.
Yep.
half of the project is in Mali, half of it is in Specs 2, and then
that's a
there
little
is a
bit
glue code somewhere.
That's a little bit the sad part, that we don't have one solution that everyone will use, because Mali, for example, now has a nice tool which lets you emit CLJ Condo information, so you get the specs that you write for your functions will also be used for linting.
Yeah.
And if everyone would invest in these type annotations, we could have really good experience also using this for linting, which gets you like maybe 50% of the benefits of static typing.
Yeah.
I'm not sure, but
No, that's science. I think you just came out with there, Michiel.
But it surely will give you a lot of benefits if everyone uses the same approach and commits to it. And now we have all of these separate solutions. Yeah,
and maybe it's a good. I know CLJ Condo is more like a foundational tool now in Clojure development. Pretty much in every tool, which is super awesome, by the way. Maybe it's a good idea to people who still don't know about CLJ Condo to tell them what it is.
Yeah. So CLJ Condo is a Clojure linter and also a static analyzer which can emit information about your code, but it's primarily known for its use as a linter. It just spits out information about if you call functions with an invalid amount of arguments, for example. It can detect type problems. So if you call the inc function with a keyword instead of a number, for example, it will tell you, oh, you've done something wrong. So in general, it prevents you from making silly mistakes while you're typing your code. That is the main idea about it.
Yeah, and it is now basically included in every IDE that we use, right? It's plugged into Cider, LSP, Calva, VS Code.
Yeah, so how it works, so CLJ Condo can emit information. If you type a function, it will emit a namespace element and a function element and the name of the function and the arities of the function. And so it can be used as a library to get this information. And then you can build tools on top of this. For example, Clojure LSP, that is a tool which implements an LSP server for Clojure.
What is LSP, Michiel?
Yeah, I will explain it. So it uses CLJ Condo to do the code analysis, and then it implements the LSP protocol, and it stands for Language Server Protocol. And this Language Server Protocol is invented by Microsoft. Initially, it was for VS Code to implement a server that's running in the background, and then the editor talks to the server to get information about to do things related to your code, and also for linting.
Yep.
But this then got the protocol got, I think, standardized. I don't know the exact history, but I imagined it went like that. And then other editors also implemented clients for this. So using the same server that you're using for VS Code, you can now reuse this, for example, for Emacs. If you build a client in eLisp, then you can reuse the exact same server to get linting and code navigation features and completions for Emacs or for IntelliJ or for any other editor that can talk to an LSP server.
Nice.
Yes.
Yeah. So it's now used in Calva.
Yeah.
So before I've written an LSP server myself, which only exposed CLJ Condo information, and this was a separate extension that you had to install from Calva in VS Code. But now Calva, they use the Clojure LSP as a library, and that LSP uses CLJ Condo again. So now you don't need to install this separate extension anymore.
Yeah.
So you get it basically bundled with Calva. I recently started using Clojure LSP in Emacs. Yeah, it's really cool because you get the navigation that you usually need a REPL for. You now get only using static analysis.
Yeah.
So even in Clojure script, I'm usually too lazy to set up something like a REPL. And now I get all this navigation after years of not having this in Clojure script, I finally get this again. So
Yeah.
I can see the benefits.
Yeah, but it's been really nice that, as you said, in Emacs, for example, or any other editor, now there is a nice foundation of common functionality that you can get in every editor, regardless of what editor that you use. But obviously, you should use Emacs because the rest of the shit is a piece of junk
course.
anyway.
Yeah,
So
I agree.
people can people can finally experience some of the features across all different editors.
Stop beeping me out. We got louder. Yeah, suddenly there's problems with the internet.
Yes, I think this is something that you're doing, right? I think you keep like somebody said Emacs, somebody said Emacs on the internet. Let's bring down the internet. But I don't
we'll
know
get
if
him back in a minute.
But you use IntelliJ, right? Is IntelliJ also using LSP? You know that already, or they have their own parsing?
I don't think they use LSP because I
mechanism.
think IntelliJ basically has a very complicated indexer that does all this static analysis. That's what I think Cursive relies on as well.
I think there is like MPS or something in IntelliJ. They're like a special, something.
Yeah, okay. They do. Yeah, they have a different language protocol basically of their own. And then I think he extends the MPS to for Clojure. But yeah, I mean, I think a lot probably. I don't know if he uses Condo either actually, because I always use Condo for myself. What we tend to do is we put Condo into CI and we do it on the command line before we check stuff in. But I don't have it as a sort of real-time feedback in the editor.
Yeah.
Do you have it set up like that?
No, I just use Emacs and then Emacs with LSP recently, and then it's always been Emacs with REPLs mostly, but these days with LSP. Once it was released, I think a few months ago, or maybe a bit. Hello, yeah.
Yeah, I don't know what happened.
So we were just talking whether IntelliJ is using LSP or not. IntelliJ IDE or Cursive.
No. So Cursive has its own. I think IntelliJ has its own model, and Cursive builds on top of this model.
Musical instrument that you play with by waving your hands in the air near antennas, and it goes. It's pretty neat.
So do you know ghost sounds from?
Okay.
Right. Okay.
Take two. Well, it's just 30 minutes. So
I think we should keep Michiel away from computers from now on.
Yeah.
maybe Zencaster isn't using CLJ Conda in their CI.
I think
that's the problem.
Yeah.
That is definitely a huge.
That should have fixed everything.
Yeah.
So, are we going to start again?
Yep.
What do you think? I mean, do you think it would have kept some of those files?
Yeah, it did, because I can see recording one. There is enough of content there. So we can continue talking about
Emacs LSP and IntelliJ LSP.
Exactly.
Yeah.
So we were just talking about whether IntelliJ is using LSP or not, and also IntelliJ using not IntelliJ but Cursive probably Cursive using CLJ Conda or not.
No. So IntelliJ has its own model of the code. I'm not exactly sure how it works, but it's a proprietary thing, or maybe it's open source. I don't know. From JetBrains, and they use their code analysis. All uses that framework, and Cursive, I think, uses that framework.
Yeah, that's right.
It doesn't use LSP or CLJ Conda, but you can install in IntelliJ a plugin for LSP, and then you can also use CLJ Conda, the LSP server, or you can use Clojure LSP, which is the full Clojure LSP project with the navigation and completion and Sailor Condo included.
Okay.
But what's the point though? Because you get all the navigation from cursive.
Yeah, that's true.
I guess you have to pay for cursive, so maybe that's the
that's
true.
true.
Don't want to do that.
But maybe Clojure LSP has some function or some features that cursive doesn't have, or at least you get the linting from Sailor Condo also. But I'm not sure. I haven't used cursive that much, so I'm not really able to compare.
Yeah,
because you get a lot of. I think CLJ Condos have got more features than the cursive thing does. But it for instance, when you're editing Clojure in cursive, it will tell you things that are wrong. Like it will tell you where things aren't being used. For example, it will grey out parameters that aren't being used, or requirement, or defs that aren't being used.
Yeah.
But it doesn't. Funny enough, it doesn't work. Like I think where Condor works better is like if you refer a variable, for example, refer a function, it doesn't catch that in cursive. But obviously, CLJ Condor catches
so
that.
If you don't use the referred function, you mean?
Yeah. So in that case, it doesn't catch it. So what I do is I tend to edit with cursive, and then before checking the code in, I will run the CLJ Condor just as a final check.
You could just make your life easier by using Emacs and LSP. So
yeah.
Well, it's like Spec 2, It's like one of these days it will happen, I guess, but it takes a lot of thinking about.
Yeah. Anyway, so but CLJ Condo is also in Vim thingy, right? Vim Fireplace, or there is a different plugin for that.
I think so. I don't know much about Vim, but I see a lot of mentions about Vim Iced these days.
Yeah,
which is made by I think a Japanese or Chinese. I think Japanese guy who also provides some extra features. If you have CLJ Condo installed, then it will call out to this binary to also catch this analysis information and also do some stuff. But you can also use LSP from Vim, and then you get exactly the same features as in Emacs or VS Code. So it's nice that you have to just write one thing and it gets used everywhere. That's a big win.
Yeah. So the basic editing experience of these terminals can be similar.
Yeah. Yeah, that's is that an insult? Basic?
Yes, absolutely.
Yes.
Thank you for catching that, Michiel.
Of these terminals,
he was exactly. He was thinking that terminals are inferior. And then that's basically what he.
The mainframe editors can all have the same performances.
I think this is coming from a guy who's using Linux on his desktop. So
what's wrong with that? That's a good thing.
Half the shit on Linux is on terminal, right? You don't have fancy
absolutely
UI
not.
for all those tools.
There's a totally tendentious argument, fallacious. No, I mean, the fact is that Linux is really good. You can buy very, very cheap hardware and use it and have a great desktop experience for Linux. Otherwise, idiots like you buying these Macs for spending $3,000 or $4,000 for a piece of crap computer.
Yes, exactly, and that is also
I can
the reason
spend a
why
quarter of that and get something much better.
That's also the reason why you spend 2 hours figuring out why the fuck headphones are not working. Meanwhile, I'm already recording some shit.
Oh yeah, because this has been such a smooth recording experience, VJ.
That's Zencaster. I think we can complain about Zencaster, without any issues. So
okay.
Anyway, I don't care if it is any type of computer, as long as I don't need to spend time tinkering this shit. So it's
Well, I think the thing
those
is
days are over from me.
Yeah,
so.
but I mean, I think the whole point is that everyone's got some kind of like cost-benefit analysis to do anything, So yeah, I mean, if you just want to get some reliable hardware, Mac's great. If you don't know much about hardware, if you can put together your own computers, than
Well,
like
that's what I
do.
did when I was a kid, and not anymore. Building
Oh,
those,
ouch!
building those, building those all these fucking gigabyte shitty laptops, and then trying to figure out all the crap with a turbo LED and that doesn't do anything. And
Yeah,
this
but I mean, these
this shit
days,
happened in the past, and
I
yeah,
know,
yeah,
but these
yeah,
days you can basically go on the internet, get a PC builder. It's pretty
yeah,
it's pretty trivial,
that's
I
true.
get my sons to do it. They've not having got much experience, but they can put together a PC in half a day.
Yeah, yeah, yeah,
And it all works very, very reliably. And it's like I
yeah,
say, it's a quarter of the price of a Mac.
that's
And
true.
it's
Yeah,
got far more. It's got twice as much memory and more cores and all this kind of stuff. So it's a bit
yeah,
like people who want to use Emacs. You put the investment up front in terms of learning the technology, and then you reap the benefits later.
yeah. But it's not like it doesn't, especially once you these days, because all the developer tools are available on pretty much all the platforms. So it really, given Windows as WSL now, basically whole Linux simulation layer. I think we'll talk about it a bit. And I think Michiel is already experimenting with WSL. So I'm curious where he is at, because I tried WSL 1 and then WSL 2 a little
Yeah.
bit, but I'm like,
Yeah,
fuck it.
I've also
Yeah.
built.
Go on,
Sorry.
Michael.
Yeah.
No, go on.
So yeah, I did build a PC as well during last year in the pandemic because a lot of people were talking about it. Well, we're in the house anyway, so let's not use laptops anymore. Let's all build a PC. So that's what I did as well.
Yeah.
And so the first thing I tried was installing Ubuntu, but then my video card drivers didn't work, which was expected.
Yeah. You
And
should
then-
have checked the wiki for
yeah.
supported video cards.
Eventually I got it working. So but it takes some time. And but I was also curious about WSL2. So I just installed Windows as well, and then WSL2 on top. So WSL2 is a Linux, kind of a virtual machine, but not really. It's something more integrated into Windows, but it uses, I think, hypervisor technology to run a Linux system, and this really works really smooth. So you just install this, and then it basically is. Well, you can install Ubuntu, and then you can run all your tools. But if you then start VS Code, for example, you can edit natively in Windows, but it will connect to your programs in the WSL2 environment, like as if it's the same system. It's a really smooth experience.
Yeah, I think WSL2 is way more impressive compared to WSL1. I think WSL1 has more in terms of the integration. I think WSL2 has more kernel level integration. I think so. The file system acts faster if you are copying between Linux and Windows, and that made the whole experience super smoother, I think.
Yeah, I don't think that's the most performant bit, copying from Windows to Linux, but I think they improved that as well. But that is still pretty slow compared to copying from
native.
The same.
Yeah.
But so in general, I think you should just do all your development stuff in the WSL2 and maybe the graphical part in Windows itself.
Yeah. Why would you use Windows though? I mean, I'm not joking about that, because I think Windows is a really terrible operating system.
Yeah, I don't disagree.
No,
but,
I mean, I'm not even joking. I think it's just awful.
Yeah. I don't disagree, but for me personally, I make all these binary programs for Sail Condo. I distribute binaries, and for Babeshka as well, and some other tools. And I just want to be able to test this on Windows as well. So
okay.
And so I can do the compilation on Windows itself natively and in the WSL2 in the Linux environment. And I do have a Mac laptop, so I can test out very easily all the three main operating systems.
Right.
And the Windows WSL2 system, it's a very fast system. with a Ryzen processor and 128 gigs of memory. So it compiles Babeshka twice as fast as on my Mac laptop.
Sure.
But maybe with the M1 processor, it will change again. So
yeah, I've been hearing some good stuff about M1. I was thinking of getting a Mac Mini because, as you said, everybody is at home these days, so laptops are not really that useful anymore, given lack of travel. But I heard pretty good stuff about M1. Especially, I know a couple of people who are using M1 MacBooks, and they're like, oh, the battery life is crazy on those things.
yeah,
That's what I hear, and hopefully, when all the tools are ported properly, and maybe then I'll give it a try. But
yeah. But nowadays, I thought I would work most of the time on my new PC, but yeah, I think it's pretty convenient to just pick the laptop and sit wherever you want and then do your work. Even if I'm at my desk most of the time. So I try to set it up like I can always work from my laptop and then log into my PC using the terminal. And
using the terminal. Yeah, awesome.
Yeah, using the terminal. I actually love the terminal.
Of course you do.
So I tried all these combinations, like launching Emacs from the terminal on my PC and then working from my laptop. And also tunneling X server to my laptop. VS Code has a mode to directly edit on an SSH connection. I also tried that. I also tried Cider connecting to a REPL on my PC from my laptop, and while the files are edited locally. So I tried all these combinations.
So why aren't you using Tmux, Michiel? Come on.
I don't know. I just haven't tried it.
And you wonder why your Wi-Fi is saturated. all these things talking to each other like bazillion Eden files floating around from one laptop to the desktop to Mac.
But eventually, I only do the heavy stuff now on my PC, and then I just copy the stuff back to my laptop. That's what I ended up with, because there is always a bit of delay and ergonomics issue. So
I think the other thing, I don't know what it's like with Emacs, by the way, but you can tell me. But are the chords different on Windows and on Mac, or are they the same?
No. Well, the chords
That's
are
what
the
you
same.
call it, isn't it? A chord?
Yeah, I think so. So the key combinations, the chords, are the same, but the keyboard layout is not always the same for a keyboard which is suited for Windows or a Mac. So one thing that bugged me was the function key is on Mac laptops. It's on the far left. And on Windows keyboards is usually the control key is on the far left, and then you get the function. And this is very annoying with Emacs. I find personally. So
let's just ruminate on the fact that things were annoying with Emacs. Yeah. Okay. Carry on. Let's move on now.
Fine.
We've been around some houses here. Okay.
Yeah.
Anyway, CLJ Condor. That's. I think it's really a big success story, actually, Michiel, for you. And I think you're getting a lot of contributions, and I think people are in the community are very excited about it, because I think what you did with CLJ Condor fundamentally, and I think that was your objective, was to make the lint to something which was done in Clojure rather than in Go or some other language. So I think this has been a huge win, and obviously the benefits from GraalVM in terms of speed were the real innovation that you latched onto. So I think it's a great success. We were going to talk a little bit about the fact that with this success and this fame, you're now the recipient of the beneficence of Cognitect in their largesse, as they give out money to their winners. And you are one of the lucky golden ticket holders.
I was happy to see this.
No, it's really good. It's good. It's a good. It's a good thing by Cognitech for sure.
Yeah, I'm really grateful that they are doing this. So hopefully in the future I can work more on these tools. By having some income from these open source projects. That's really cool if that would grow in the future. But right now I'm really grateful for companies like Cognitech, and there's actually one other company who's also sponsoring me with substantial amount, which is at Goji from the Netherlands.
Yep.
But they are doing it through Open Collective. So if I would have, let's say, 5 or 10 of these companies, I could make a living of this.
Yeah.
So it's a very interesting trend to see where this GitHub donations and also Open Collective is going.
Yeah.
Because in the start of 2019, I started with Sail Giocondo, and not for the money, just because I wanted to build a cool and useful tool. But now it's becoming more serious, and and I'm really happy that it's going like this.
Because it is as I said, one of the foundational tool now, as we were saying. Like, it's part of practically every Clojure developer's toolkit now. If it is not, I think people should check it out. Stop the podcast and then install the shit right now. So
but I think it's really interesting how you've taken that though, Michiel. Is you're looking at low level tools like the linter, and then you've got these little low level tools like the small Clojure interpreter as well. And all these little tools that maybe you could describe a little bit about what your motivation is for some of these other little, not little in the sort of impact sense, but they're kind of like piecing together little bits and pieces. Maybe I'm underplaying it. You tell me a bit about what your kind of strategy is for a lot of these tools as you bring them together.
So it started with Sail Giocondo. So I built a tool that could analyze arbitrary Clojure code and then spit out some information about that. And I compiled this using GraalVM native image. So it had instant startup, and you can just invoke it from the terminal and have instant feedback. And I thought this was really cool. And it took me, it crossed my mind a couple of times to also build a Clojure interpreter with instant execution instead of only linting. So you can execute arbitrary Clojure expressions from the terminal as a script, But because Sail Giocondo was already taking so much time, it crossed my mind a few times, but I thought, well, let's not do that because that will be a too big of a project. But until I did try it, so I started very small, like okay, just for today, let's just try to implement a let expression or something which you can execute from the terminal. And this is basically how the interpreter, the small Clojure interpreter, started. So you can execute a let expression, and then I tried to support loops, and then I tried to support functions. But initially, the only thing that I had in mind was you pipe some input to this command, and then you can execute an expression, and then it will spit out something. That is basically what I only had in mind. But
what is small in small Clojure interpreter then? So is it still small?
It started really small, like that, and but I added more stuff to it up to the point that it almost supports all of Clojure now.
So it became super Clojure interpreter.
So it supports.
I think you should call it simple Clojure interpreter just for the trolling.
For trolling, or easy Clojure interpreter.
Easy
maybe.
Clojure interpreter.
But it now supports functions, vars, namespaces, multi-methods, macros, of course. First, it didn't support macros, but yeah, after a while it did. And so it went on and on. And so the main differences now with JVM Clojure and the small Clojure interpreter is things like where the Clojure compiler emits new classes. That is something I cannot do in the small Clojure interpreter because it runs in, or you can use it with GraalVM native image. And once you have your native image, that is a closed world. So you cannot create new classes while it's already compiled.
Yep.
And this is where I need to come up with some workarounds in this interpreter. So things like protocols, they emit new classes in Clojure in the JVM. So, but in the interpreter, I just have to work my way around this basically.
So is the idea, just to sort of back up a little bit, is the idea that SCI is something that's used via GraalVM, so it's pre-compiled, and it's not dynamic like Clojure is. Is that the headline news?
Yes. So the difference, so the use case is you want to create a GraalVM native image, which has an instant startup, but you also want Clojure evaluation. And this is something you cannot do just by calling eval from Clojure core, because eval will use the compiler to emit bytecode, and a native image cannot execute bytecode. It has already compiled this bytecode to native.
Some object code, yeah.
So you cannot do this at runtime anymore. So instead of using bytecode, bytecode compilation, I use an interpreter. So it just parses your string into S expressions, and then it interprets those S expressions instead of emitting bytecode. So this is the difference.
So how does it manage to interpret them rather than evaluate them then?
Yeah, so this is that's basically the goal of the library, to interpret these things. So the interpreter is built from a couple of components. So obviously you have the parser, which goes from a string to S expressions. And then you have something called the analyzer. And the analyzer tries to optimize the S expressions in such a way that it's fast to execute the forms. So for example, if we have a do expression, so let's say do and then print foo and then print bar. So you have two things in the do block. What you can do is just walk over all the expressions in the do block and then execute them using a loop, for example. But what you can also do, and that's an optimization that I'm doing, is that you analyze each expression beforehand and then save those expressions in a local, and then just when you evaluate the entire do block, you just look up the expressions in the local instead of looping over all of them. So you can unroll, let's say, these do blocks. So I have a couple of macros that optimize this for like 20 up to 20 expressions or so, and if you have more than them, then it will use a loop, for example. So this is done in the analyzer. What the analyzer also does is look up var references and class references. So if you say inc1, then it will look up the var inc in the analyzer, and then it will emit a form that just has a reference to the var directly, instead of looking it up at evaluation time, let's say. So if you evaluate this form multiple times, you don't have to look up this var all the time.
Okay.
So these are the things in the analyzer, and the analyzer then emits expressions that, let's say, the evaluator is what I call it, then executes those expressions.
Do you build all this from scratch, or are you using some sort of pre-existing tools?
Yeah. So I took care that all of this works with GraalVM. So if you try to do this using, at the time at least, tools reader directly for Clojure, that is a parser for Clojure.
Yeah.
Then you would run into some things related to eval, which were not possible. And maybe right now you can work around this, but there was also a bug, or not really a bug, but an issue in Clojure related to the locking macro. So GraalVM did not understand the locking macro in Clojure, and this was also an issue with lots of projects at the time that you were they just didn't compile with GraalVM. So I basically rebuilt everything in such a way that it works with GraalVM. So the parser, it is using basically only the Eden parser from Tools Reader, because that ensures that there is no evaluation happening. And then I added some stuff on top to get better location information. So in the interpreter, you have information about all the symbols as well, instead of only the lines.
Right.
So if you type top level symbol in Clojure, you will not get location information about this. But in Psi, you will get on line 20, column 4, there is an unresolved symbol X or something.
Oh, nice.
So that is also what this parser does. The parser is called edamame. And it's also configurable. So you can say, I want to parse only Eden plus this little thing on extra. And or you can say, I want to parse full Clojure syntax. So it has this configuration, but I'm using this parser in the interpreter. And it's pretty much built from scratch. I don't really use any libraries except Tools Reader.
Yeah. So obviously the interpreter is more or less, you would say, complete in terms of the features that you want to have, or there are more things that you want to add there.
Well, I think it's pretty much, let's say, the first 80% are always the easiest.
Yeah.
And so it supports the basic things you will need for scripting, like up to def record, let's say.
Yeah.
But after that, even def record is a little bit of an edge case, because in Clojure itself, in the real Clojure, let's say, it will also emit a class. So that's already where I have to, if you say def record foo, and then you say instance foo, and then you create a record, then it should return true.
Yeah.
So even there already, I have a patch in my instance function, because I don't emit these classes, but I still wanted to return true. So I have I have some workarounds there.
Okay.
Yeah? So this is def record. And then there are things like reify. So you want to reify interfaces and protocols.
Yeah.
So before yesterday, it was only possible to reify protocols or interfaces, but not both at the same time. And the reason is, again, that in GraalVM native image, you cannot emit new classes. So what I did before yesterday is
breaking news on the podcast. This is incredible.
It is incredible, yeah. So what I did is
you heard it here first.
Yeah, it's breaking news. So what I did to support reify before is
it reify? Is it because it's me?
It's Rayify. Yeah.
Yeah, you were thinking, I'm coming on the podcast. Let's do something for Ray. Okay, I appreciate it. Yeah.
Yeah. And we will get to VJify later.
So I think if you do VJify every function and it keeps returning just one string saying use fucking Emacs and move on. Nothing else. And it doesn't matter what you write in the body. It always returns just one string that says use fucking Emacs. And shut up.
But let's say for the last 20% to support to get more Clojure compatibility, because that's one of the goals, right? To have a scripting tool that supports most of Clojure.
Yeah,
and also can run libraries from the Clojure ecosystem from Clojure. So you can just say, I want to use this library, and then it hopefully works. Because that is currently not the case with every library. So if your library uses def type, for example, it won't work today.
Yeah,
because def type is the most low level thing you can have in Clojure. So I don't have a good answer to that yet, but it might be coming in a couple of months. I don't know.
But just before you go on, Michael, I mean, so like you're talking about these like 80%. I mean, is that, when you look at the libraries out there, have you got a decent corpus of libraries that are supported?
Yeah. I have a link on the. So maybe I should also explain that. So the interpreter is called SCI, SCI, but this is a library, and this library is used in Babeshka. And Babeshka is the interpreter compiled to GraalVM with GraalVM, but with a selection of libraries built in suitable for scripting. So this is basically an application that is built using SCI. But SCI also compiles to JavaScript, so you can also use it from JavaScript. But about library compatibility, so in Babeshka supports something like a class path. So you can say, I want this library on my class path, and but not all of the libraries work. So we do have a page with a list of libraries that work with Babeshka in the documentation. It's called doc/projects.md. There is an entire list there.
No, nice. So because you said CLJ Condo, going back to CLJ Condo a little bit, because what are the next plans for it? So where do you want to take it? Is it going to be like you're going to introduce the rest of the 50% of the static typing, or what is the idea?
So one relatively new feature in CLJ Condo is it also uses the interpreter now, but for macros. So if you a user can now write a hook to expand your macro calls, let's say, to get better analysis for macros that CLJ Condo doesn't understand out of the box. So this was recently added, or maybe half a year ago already, but that is still an area of improvement to add more abilities to this, so people can do more, so they can emit also linting warnings during their hooks, for example. This is already possible, but I think it can be improved. I'm constantly working with the LSP team as well to give them more data to improve LSP. So that is an area that I think I will work on in the future. And then there is a pretty big list of things that are still to do, but it's mostly small stuff, not really any big topics, but more finishing touches, let's say. For example, in CLJ you can lint CLJC files,
Mhm.
but so if you have you just type the letter X, you get unresolved symbol. But for both languages actually, or for both, because CLJ will lint the CLJC file as if it's Clojure and Clojure script. So it will lint it actually twice. So if you you will get the warning twice, but it's deduplicated before it's printed.
Oh.
But if you have a function and then you have a branch, so you say you have an argument to the function x, but you're only using it in the Clojure branch, let's say, you will still get a warning that x is unused because you don't have a Clojure script branch that uses it. And this is sometimes confusing people. So maybe we will add something to the warning, like it's not used in this language, but it is in that other language. And this is why you get the warning, for example. So these are the finishing touches, let's say. But there are always,
What were the things that you were going to? What are the things that you were contemplating around spec on? On CLJ Condo.
Yeah, so that's one of the things with Spec 1 and Spec 2, right? So I'm not really investing a lot in this right now because I know that Spec is going to change.
Yeah, sure.
So I'm kind of waiting for that. And then once Spec 2 is there, I think I want to support analyzing specs statically. So you get also type related lintings for this.
So if you make an fdef that doesn't conform to the actual function that you're trying to fdef, for example,
but also if you fdef that the first argument is an int, and then you call that function with a string,
right?
That you also get this linting for free, you know. And this already works with Mali. Not because CLJ has support for Mali, but because Mali built a tool which can spit out information that CLJ understands. So any tool can basically do this. So if you write your own Mali or spec, you can write a plugin for your validation system to spit out this information to make CLJ understand the types for your function. But this is also something that still can be improved, I think. So there are all of these areas that are there already, but they can be improved. So yeah, that is my plan for the future, just to make CLJ more stable and more a good out-of-the-box experience for the mainstream Clojure developer, let's say.
Yeah. Well, I think it's already pretty awesome. So yeah.
Yeah. So
cool.
One thing that was also recently added is support for the Clojure core match macro, which is a pretty complicated macro because it has a lot of syntactical constructs that introduce new bindings.
Yeah.
It was on the list already for 1.5 years, but I finally did that a couple of weeks ago. So, and there are several of these things that are on the list. So the more I think out of the box this works, the better it is, because for beginners it's not so nice if they install a tool and then it yells at you for something that's not wrong, right?
Yeah.
So
you did something else as well, didn't you? Like you're talking about like using specs to look things up. Was it Grab or something that you did?
Yeah, it's called Grasp.
Grasp, not Grab.
So it's a little bit of a
means the same thing in English, so that's why I think.
Yeah. I think there is a JUX library called Grab.
Of course.
So I'm operating in the five character libraries. So but so it's called Grasp, which is the pun on grep. And what you can do is specify. So what it does, you can search through your code base or through your entire Maven repository, for example, for shapes of code. And these shapes you can describe with Clojure spec. For example, I used it today to see which interfaces and protocols people are using with dev record in general, because that is something I want to support better in the interpreter. So I built a spec that says it starts with it's a list, and then it starts with the dev record symbol, and then then you have a name, and then you have a vector. But I'm interested in the rest of that. So it grasps your entire M2 directory, for example, and then it will give you the S expressions of all the dev records that you were interested in, and then you can do some post processing on that. That's basically the idea.
So you cloned entire Clojures into your M2.
So what?
So you cloned entire Clojures into your Maven repo directory.
So I just analyzed the M2 that I had.
Okay.
Yeah.
Is that something that could be done now? Is that you could like talk to the Clojures people and get access to their?
I am actually talking to Toby. I think it's Toby. Yeah. About this, because I also made a tool recently which you can throw some Clojure code at, and then it will tell you which dependencies you actually needed to execute this code. So if you say for example, I have medley.core/index_by. I'm using this, but you don't have medley in your deps.eden, then it will tell you, I found a library in your M2 directory which actually has this function. So you probably need that one. But I actually want to build some integration with Clojures. So I proposed to Toby to make an index of all namespaces to
the jar files,
jar files, and more information about which file in the jar contains this namespace. But he's currently working on something else related to the, I think, domain names. So you cannot create organization names that you don't own anymore on Clojure. So he's first doing this. That's already
that security problem recently.
That's. But after that, he might look into that. So then I can integrate that with my tool to look up by namespace libraries on Clojures that you might need. But I can also use that index to download all of Clojures. and then do
that's what you built a PC for, right?
Right. Exactly. and then do all the analysis on that. But I'm mostly interested in like, let's say, the top 100 things that are occurring in a general Clojure code base.
Yeah, sure.
So that is why I built this tool. And I also used this grasp tool to find out. There was a recent discussion in the Clojure dev channel on Clojurian Slack about arrays of assoc, the function. Because if you call assoc with more than one key value pair, then the performance becomes slower, because it does first and last or first and rest over the arguments a couple of times. And that could be optimized by introducing more arrays in the assoc function. And then there was a discussion, but people usually don't call it with more than 2 key value pairs. So and this was an unscientific claim, basically. I don't think it's worth it. But then I used a grasp to do some research, and I posted this research on the Jira to actually see how people are using assoc with how many key value pairs. And I think we even found a library where they had 20 or 30 key value pairs.
Wow.
Yeah.
But that was definitely not the common use case. But so
Well, there's always a bell curve here.
yeah.
So there is a way now to actually get your features into Clojure. Just go and create open source projects with the features that you want, and then make Michiel index those projects, and then prove that as a data point. And these 200 projects are using this shit. I don't know why, but it must be popular.
Yeah. So it's kind of, this tool is kind of a spin-off from doing research for my interpreter or for Sale Condo.
So no, it's really good. Yeah.
Fascinating. So, wow, I think we almost have 1 hour of recording, hopefully, unless we're missing any other topics. Obviously we can talk about Babushka a little bit, maybe. Give us an update on what is happening in that world and how it is being used.
Yeah,
I think what I remember from, I think last time we spoke about Babashka, it was just coming out. It was just coming, I think, or being released, but it wasn't. I think you've done a lot of work in it since then.
The last time I was on on Devin podcast, Babashka wasn't even a thing yet. It wasn't. There was nothing. So I only had Sale Condo then, but I started working on this when I was on a vacation in Switzerland in August 2019. And then, right now it's being used by quite a lot of people, I think. So it has 1,800 stars on GitHub.
Yeah, nice.
Well, yeah, it's very good.
And I have a Slack channel with almost 500 people now. So I get daily, I see posts on Twitter of, I made this script and it does this thing, and now I don't have to write it in Bash anymore. And so these are, and this, you could already do this a year ago, I think. But so it's always the last 20% that gets the most work. And so the last year I've added several features to Babashka, so better integration with the tools depths ecosystem. So you can say in Babashka itself, you can say require Babashka depths, and then you can say depths, add depths, and then you can just put a depths Eden map in there. And then it will download the libraries for you and put those libraries on the class path. So you can just do this from one script. And it will use the real tools depths actually. So it will require JVM when you want to add these libraries. But if you invoke it the second time, it's all cached, so it's then it's very fast. But I'm also experimenting with making tools depths itself native. So I already have a working version of this. So then you won't even need a JVM for this anymore. So entire tools depths is native, and it downloads your dependencies and without this JVM startup.
The other thing I remember that you did, I thought was very interesting, was take the Clojure script, the Clojure Bash script, and made that work on Windows. Because that was, because that was a bit of a sore point, wasn't it, for some Windows users for Clojure?
That's true. So the current Clojure CLI on Windows is only supported from PowerShell, and it's very awkward if you want to shell out to this thing because it's wrapped in this PowerShell function or something. So it's and you cannot use this from command.exe, so you always have to use PowerShell, and there are some weird edge cases around this. So what I did is port the Bash script to Clojure itself. And now you can run this Bash script with Babashka, and this works on every operating system because Babashka works on every operating system. But I also made binaries out of this, so you can also just run run it directly in a binary, you're just using GraalVM. That's called deps.exe on Windows. So you just download the binary and then it works. So this is only a re-implementation of the bash script and not toolsdeps itself. So
No, sure.
Yeah. So it's only, let's say, the front end. But I'm using this same front end is now used in Babeshka as well to download these deps. That's exactly the same code.
Right. Okay. Yeah.
Nice.
Yeah. So another thing that I added in the last year was pods. And so Babeshka pods are basically other...
You're ahead of Rich Hickey in this sense, I think.
Yeah.
Sorry?
You're ahead of Rich Hickey in this sense.
Yeah,
I think he was going to have pods at one point.
Yeah,
but, you know.
maybe I will have Spec 2 in the next...
the next version of Babashka. The small Clojure interpreter will have Spec 2.
I think you have the whole ecosystem, right? You have the interpreter, you have the linter, you have the static analyzer, you have a shell, so pretty much everything.
Hello.
Oh, we lost him again.
Are you still here?
We're almost there.
Oh, Jesus.
Could be his internet. That's my...
Could be. I think he's downloading Clojure as we speak.
Yeah.
Fuck. That was a shame.
There is this...
Here we go.
there is.
Okay.
Are you still here? Yeah?
Yes.
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 Okay. So I can just keep on talking.
Just keep on talking. We'll just chop that bit out. Yeah.
Okay. So what was I saying? So the pods, right?
Yeah.
So the Babeshka pods are basically binaries to... Normally you can shell out to binaries, you know? So you can... So for example, you have a script and you want to shell out to SQLite, for example, to save some data. Then you can shell out using Clojure Java shell, for example, and then send some SQL. And then if you want to select some SQL or some data from the SQL database, you can shell out and then you get it in a CSV format. And then, so that's a little bit awkward. It's not nicely integrated. And this is a problem that Babeshka pods are saving or are providing. So you can, for example, use the Babeshka SQLite pod, and then you can call functions that do kind of an RPC call to these other binaries. So a pod is another binary which Babeshka talks to, as in more or less an RPC-like fashion. So, but it is as you are basically just calling functions. You cannot really tell the difference as a user.
Yeah.
But this is just a way to extend Babeshka with stuff that is not supported from source. So you can run libraries from source, but this is not always possible if those libraries have classes that Babeshka doesn't know about, because we cannot interpret Java classes, for example.
Yeah.
So then you can build a pod, and then this is a way to then extend Babeshka. But a pod can be written in any language and not only Clojure, for example, as long as it exposes the right protocol.
Yeah.
So you've got a FFI now.
It's kind of an FFI, yeah. It's a more or less high-level FFI, because the interop happens using JSON or Eden or Transit. So we're just sending Eden over the wire, basically, as if you're talking to a web server.
I think that's the future of all FFIs, so it's all good.
Yeah, but
nice.
in scripting, it's for typical scripting tasks, it's very fast. So I recently implemented a buddy pod. So buddy is a library for Clojure for hashing. Well, it has more, but it has a hashing namespace. So I'm exposing that through the pod. So you can say load pod org babeshka buddy, and then you say require pod babeshka body, and then you can say babeshka body hash some weird hash algorithm, and then this data, and then it will just work from there without without babeshka having to bundle the entire body library, because this will also make babeshka bigger and bigger. So this is a way that we can delay or not
compose
include
things.
we can compose things without including everything in one big binary.
That's perfect.
Yeah.
Nice. I think all these tools are like, it's like alternative Clojure tooling that you're building, the whole stack, step by step.
Yeah.
The other thing I think with Babashka as well, you have a web server in it now, don't you?
Yeah, there is.
Emacs is going to come into it next, I'm sure.
Yeah. Well, it will support eLisp maybe.
Yeah, I think that.
But
that's the goal.
There is HTTP-Kit server.
Yeah.
And the client is also in there, so the HTTP client. But you can now. Someone recently built a script that re-implements Python HTTP server command in Babeshka. So you will just see all the files on your file system in the current directory. And that's now very easy because of this built-in HTTP server.
Yeah.
So there was a lot of attention or work done on libraries as well. So we have a Babeshka FS library, file system library, which is a wrapper around Java Neo stuff, basically, which is not so nice to call from Clojure because you have to create all these arrays for all the options at the end.
Yeah.
And so this is all Clojure-ified into a nice library, which also is bundled with Babeshka. But the libraries you can also use from the JVM. So it's all, that's the nice thing about Babeshka, is that all the code that gets written is also reusable still on the JVM. So it's not an entirely separate ecosystem in that regard.
Yeah. The thing, interesting question for you actually is like like obviously if you know Bash, I know Bash quite well. I've worked with it for years, and so and I know Bash better than I know Clojure probably. But the trouble is that there are certain things in the Bash that just are really horrible to work with, like JSON. Actually, JSON is a total nightmare to work with. So you have to use some third-party tool like JQ or something like that, which is also quite, again, a bit of an awkward tool. The syntax isn't exactly perfect, and it's kind of annoying to again learn other tools outside of the Bash itself. So I think in that case, Babashka seems to be fitting very nicely because, often you do want to have a web client that consumes something and get back some JSON. And if you want to do that in the Bash, it's quite annoying. Whereas with Babashka, it becomes trivial.
Yeah. Yeah, that. Yeah.
I'm trying to sell it to you here.
Thank you. Yeah. Well, I might try it out. No, that's
I'm trying to think of other use cases where because if you're just doing one-line bashes, then I think it's very hard to make the investment. But
that's true.
But where you've got these like use cases, like
the threshold is around 5 lines of bash, I think.
Right. Okay.
I call this the number 5. I use this in 2 ways. So more than 5 lines of bash, you use Babeshka. Right. But if the Babeshka script itself takes longer than 5 seconds, you use the JVM.
Right. Okay.
So this is kind of the progression. So because the interpreter is not as fast as the JVM, because that is compiled.
Yeah.
So you start with the bash script, and I think a lot of people before Babeshka, they just stayed in bash because or they used maybe Lumo or Planck or maybe Joker, which is an interpreter in Go. but usually maybe they stayed in Bash, and they didn't even occur to them that they could use Clojure for build scripts, right? Because it just takes 2 seconds to run it, and the JVM is too heavy for these simple scripts. And now you can do this in Babashka, the simple scripts, although it can run quite some complex libraries now, like HoneySQL, for example, and so it runs like 2K lines of Clojure in 100 milliseconds, let's say. So it's not only small scripts, but if you have lots of loops and numerical intensive computations, let's say, then the performance is not as good as on the JVM. So if you have a lot of this complexity, these loops, and then the script might take longer. Well, definitely not longer than in Bash, but longer than on the JVM. So, and this is where you, I think, have to draw the line. If your fans are spinning and it takes longer than 5 seconds, go to the JVM.
So if you're parsing very big log files or something, it might not work out so well for Babashka.
Well, it's more like the executions per second that you So log files might be okay because that is just calling into a native compiled function. But if your interpreted functions are in a loop, let's say,
okay,
then it can become slow. But for typical scripts, I've never actually seen this as occur as a problem, as a performance problem. But people might try Babashka from the JVM perspective, like, oh, it's the same, but with better startup. But for some programs, like, don't do machine learning in Babashka, for example.
You have Excel for that, so don't worry.
Right. So use Excel interop.
Yes.
But
use a pod.
So this is a rule of thumb. Like, if a script takes longer than 5 seconds, maybe use the JVM. And then if you're on the JVM, you can in turn use GraalVM to compile that to a native image. And then you will again get the fast startup time. So 5 lines of Bash, Babashka, longer than 5 seconds, the JVM, and then GraalVM native image.
One of the things that, I mean, I don't know, you tell me actually, one of the things that sort of, and again, you're probably, you're deeper into it than I am, but one of the things we talk about here is like there's a tool chain now. We've got Clojure, and that's a relatively, you just fire up Clojure, you've got your editor, and you've got your tool chain. And as soon as you start using things like Babashka and Psy and all these other things, and then it's the tool chain and Graal, then the tool chain becomes a bit longer. So are there any? What has anything happened in that world to kind of make that a bit smoother, to make that tool chain experience a little bit less kind of like I don't know, a bit less annoying.
Clunky.
I'm not sure.
I don't know. I mean, maybe it's not annoying. I don't use it enough.
So from a user perspective, if you want to use Babashka, the only thing you have to do is download the binary, and that's it.
Oh no, I get that. I'm just talking about like if you want to use GraalVM, and you've got your, because like you say, you're looking for a startup time. So you've written these programs which are targeted at sort of like small running programs.
I get what you mean. So if you want to get started, let's say with the GraalVM, and you want to compile something to native, there are a couple of tools for this. But I generally avoid all these tools. So what I usually do is download GraalVM. It's just a zip file from Oracle or the Oracle GitHub. You unzip this, and then it's in my downloads folder, and then I set a environment variable GraalVM home. This is in my ZSH initialization file somewhere. And I change this every season, because every season there is a new release. And then I usually copy scripts from my previous project, which just have all the options that you typically need for a Clojure project, and then that's basically it. So the main thing you need to do is write a main function like you're used to with an uberjar. Usually, if you want to invoke that using Java -jar, you need a main function, and you can just make the uberjar and then pass the jar to GraalVM, and then it will compile it.
And does GraalVM immediately kind of spew if it knows that it won't be able to make a native image out of these things?
Yeah, it will complain if you, for example, try to use Clojure eval, then it will complain about dynamic class loader not being supported, for example. So you will definitely get errors.
I mean, are there any cases where you can compile it, but then when you run it, it doesn't work?
Yeah, it depends on what settings you use. So there is one setting, report unsupported elements at runtime. So if you use that, it will try to compile while there might be things that it doesn't support. And then you will get the error at runtime. But this is a trade-off, because sometimes there is Clojure code which uses eval somewhere, but maybe for a very niche case. And if you don't use this at runtime at all in your GraalVM binary, then you might still want to compile it at the cost of having this runtime error.
Right.
But you can turn this on or off. Yeah. Usually there is one thing that you usually only will find out at runtime, which is so GraalVM does static analysis on your code, but if you use reflection to interop with other classes, so you reflectively look up some class at runtime, then GraalVM cannot see this. So then you will have a runtime problem. So it will say, I don't know what this class is, or null pointer exception, or whatever. But you can solve this using a configuration file where you put a list of classes that you will need at runtime, then it will also include those. So that will also work.
Right.
It also has an agent to detect all these reflective usages during a run of a program. So you can also generate these configurations.
So in general, you find using GraalVM is not. Has it improved, or is it just
it definitely improved.
How do you how have you are there tips and tricks somewhere that you've published, or do you think that the GraalVM team themselves are doing a good job of are they aware of Clojure on GraalVM?
Yeah, so as for tips and tricks, there is one repo called CLJ Graal Docs, which has a list of tips and tricks maintained by Lee Reed and myself and other people. Everyone can contribute. So we keep a list of common issues that you can run into, but also a Hello World getting started page. I also made a YouTube video about this yesterday, so you can watch that if you want to get started. And as for so the improvement over time with GraalVM, it came from both sides, because Clojure itself also had an issue with the locking macro, and this got fixed in 1.10.2. And also some other things have been improved, like avoiding reflection warnings, for example. So if you want to do a GraalVM binary, use Clojure 1.10.2 or newer. And also use GraalVM 21 or newer, because GraalVM 21 added the capability of resolving method handles. And this is one thing that Clojure uses in Clojure Lang Reflector. There is a conditional that checks if you are on Java 8 or later. And if you're on Java 8, then it will or later, if you are on 11, let's say, then it will reflectively get a method handle and use that to do some reflection, which isn't available in the Java 8. This has to do with the whole module stuff in Java 11.
Jigsaw, yeah.
Yeah. And this was something that GraalVM could not figure out before the version 21. Okay. So that also has improved. So this combination is really good. And this combination has only existed for a couple of months now. So I think if you want to get started, you're now in a good place. And as for what was your last question? I forgot.
Yeah, so did I. Yeah. Now, the question was like, about the tips and tricks and, making sure that the actual toolkit, the tools themselves were kind of like relatively easy to use. And, my question was whether like, I know that Clojure's learned from Graal. I wondered whether Graal had learned from Clojure. But like,
right.
Yeah.
So, to summarize, you only need native image tool and the Clojure compiler. And this is basically all you need to build a binary. But as for knowledge from the GraalVM team about Clojure, I think they are aware of Clojure, but it's not a big thing, I think, for Oracle. Because for Oracle, they are mostly interested in the mainstream languages. So they are building. So GraalVM is not only a thing to compile to native, but it actually has a lot more, which is called the polyglot platform. So you can run multiple languages in one JVM. So they have something called a truffle framework. You can build a truffle interpreter for a specific language. They have an interpreter for Python, for R, for Ruby, for JavaScript, so you can combine all of these languages in one runtime. So I think they're more invested in these languages than in Clojure, but I think they are aware of, for example, what I'm doing with Babeshka. Because 1 week ago there was a conference, a workshop organized by Twitter about the latest developments about GraalVM. It was actually at a compiler conference. So there were people from Twitter, from Facebook, from Shopify, from Alibaba, who all contributed to the GraalVM compiler and made optimizations. And it was deeply technical, but there were also a couple of just developers, let's say like me, who were showing what they were doing with GraalVM. So there I presented also the work I've been doing with Babeshka. So at least some people are aware. I'm also visiting the GraalVM Slack channel. They have a separate Slack community. I'm also in there, and there are a couple of developers from the Graal team that know me, and I know them. So also issues on GitHub get responded to fairly fast, and all in all, it's a pretty positive experience to deal with the GraalVM people.
I don't know if this is. We can cut this next question if it's wrong. But isn't there something about? Is it GraalVM or is it the JVM that's doing this like multiple kind of homing environment where you can have multiple runtimes in the same JVM? Is that JVM or is that GraalVM?
Isn't that the truffle thing, or is it?
Yeah, that is.
That's what I'm thinking. Yeah. No, I don't mean different runtimes. I mean like multi-tenant Java.
Yeah, you can also. I'm not sure if GraalVM is the only one, but they recently introduced a truffle interpreter for Java. So then you can run. So GraalVM, let's say 8, can
Yeah.
run an interpreter that interprets Java 11 code. So, so you can have totally isolated JVM inside of a JVM. But that's
Right.
fairly experimental still, and so the performance is not that good yet. So it is very much research at this point. So the interpreter is called Espresso, but that might open new ways, because using Espresso we can maybe use the Clojure compiler to compile in this Java bytecode interpreter, and that we can maybe compile to native image again. And then we can maybe have something like Babeshka, but with the full Clojure and even the JIT capabilities. I'm not sure if that will work out, but it's certainly interesting to try.
Yeah, I mean, it's also the interesting concept of having essentially two runtimes where you can potentially swap the code between one runtime and another runtime.
That's going to work pretty well.
Yeah. Anyway, this is. I mean, I think the whole ecosystem around GraalVM and the JVM is still very interesting, and but I don't know about you guys, but we're on Java 11 mostly. Some bits are still on Java 8, but I think it seems like the next, is it Java 17, which is the next one, which will actually be LTS.
Yeah.
Which I think is, I don't know, they seem to be issuing every 6 months or so, so it should be like sometime this year where we get it. Because I don't keep up with any more the Java virtual machines.
I remember back in the day, like everybody's complaining like Java is not updated at all, and then everybody's complaining, and then the very moment they start releasing, you're like, I'm not going to move off of 8. Fuck you, I'm just going to stay on 8. You can do whatever you want. Like, but everybody was like, after 5 there is nothing else, and we got stuck here, and the entire world is moving, and they keep releasing every 6 months. I'm like, no, I'm not going to upgrade. I mean, I
was just wondering actually whether you actually knew, Michiel, whether there was anything worth thinking about in like these later JVMs, because I've never even thought about it. Well, I know about 11, but I don't know about anything beyond that.
I'm using 11 now pretty much everywhere. At work, we recently, or maybe a year ago, we migrated everything to 11. And
by the way, what did you say? Because I mean, I get this question sometimes at work. It's like, why should we move to 11? Everything works with 8. Even there used to be an argument that security bugs weren't getting fixed in Java 8, but now they're fixing them all. Oh, so such and such a thing like a garbage collector doesn't work in Java 8. Right, we're backporting it. I mean, Oracle are doing a Microsoft. Everything is like with Windows 8. Everything went back to Windows 8. They're backporting everything, and now this seems like Java is like the number 8. It seems to be very sticky in developers' laptops.
I think you're right. There is this Shenandoah GC from 11, so there is a bit more functionality there. Because in one of the projects, I'm using Java 8, obviously, because of the Scala, Spark, big data stuff. And in another project, we are on 13 already.
Right.
And then I already see, you're using some specific GC options that are not going to work going forward or something. So there are GC level functionality, but unless you're using Java, then if you're using a language like Clojure, then you don't see Java features as in the language features. You're only seeing the JVM features. So that's probably the difference, I think.
But I was thinking more about because obviously with Java 8 you got the whole kind of like Lambda stuff coming in, and people started in the streams. So I was wondering whether there's anything like making that again.
There is
that kind of stuff going.
I think there is properties and value classes coming in. I think maybe they are already in. I'm not sure. So there are a couple of things
I've heard that they're
like
on the horizon, but I don't think they're there yet.
Yeah, maybe that's the making Java more functional, I would say.
More like Scala. Yeah.
Yes. Meanwhile, Scala is becoming Python slowly.
But what about you, Michiel? I mean, do you notice anything from like the experiments with GraalVM about like the later Java versions? I am
using GraalVM Java 11 mostly. But also because in Babeshka I have a couple of libraries around Process Builder, for example, which is supported in Java 8, but in Java 11 they built some extra features into that. So I'm using that in Babeshka as well. So this is a reason why I'm using Java 11. And also some classes that are only in Java 11 that can now be used in Babeshka. But not really any big things. But I just have the feeling that GraalVM 11 is maybe better or supported because it's more used. So this is basically why I'm using it as the default thing.
Okay,
Nice.
Cool. The other thing I was going to, so before we wrap up, the other thing I was going to talk to you about, and I don't know if this is a topic that you're kind of like pushing a little bit with SCI, but having it as a kind of production REPL. I remember talking to you at either one conference or another. We were discussing the idea of production REPLs, and we're all getting very scared about them. But you were like, come on, let's do it. I was saying, let's do it. I can't remember. I think we were going back and forth.
I am pro production REPLs, because production REPLs give me the ability to inspect runtime state in the production, and this has helped me more than it didn't help me. Let's say. So, but you have to be careful, of course, to not redefine things or but you can always redeploy the production app when you do that, right? But you have to be careful, of course. But for inspection, I think in general having a REPL in production is very good. I'm not sure what we discussed at this conference, and also
I think it was like the concept of whitelisting certain actions or whatever, or this kind of concept where you could, in a production REPL, turn off certain, so you could read but you couldn't, you can look but you can't touch type thing. I don't know if that. I think we were just talking around that idea. I don't know if anything came of it.
I don't know.
It doesn't
actually.
matter. Okay. There was just something, because for us, we're fans of this like immutable architecture stuff. But obviously with a REPL, yes, it's immutable data and it's all immutable, but you can change things. Oops.
Yeah.
It's the one
I pretty much use production REPL only for reading things.
Of course,
but I have used it, for example, in products where I had Datomic running in production, and I needed to correct some datums or something. So I just did that from the production REPL, because that only applied to the production database. So yeah, it is a dangerous operation, and you need to be careful. But you can mess up a database also not using a REPL. So I mean,
well, it seems like that's what someone did.
It's a convenience, So but yeah, I can also see the downside if you have a team of 200 developers and you don't know who touched the REPL and messed things up. Yeah, I can see that being a problem. I've not been in such big teams yet that this was a problem. So
yeah.
Maybe at Nubank they are not doing this. I don't know.
I have no idea.
Or maybe everybody has access to production REPL there. Who knows?
Oh yeah, they're only using production REPL.
Exactly. There's nothing else.
They develop on the production REPL.
Exactly. So you don't need to have multiple environments or anything. No CI, nothing. Just start coding and then push that to Control C, Control K, and then you're done. And then just.
Is that Emacs talk for something?
Yeah.
In the terminal, right?
Yeah, in the terminal. Anyway, so wow. Hopefully, I think our previous recording was still reasonable. So we're not starting in the middle of the episode for the people who are listening. But thanks a lot, Michiel. Thanks a lot for joining us again, and all the great work that you've been doing, and which is basically helping the entire spectrum of Clojure developers, the people who are just starting with Clojure, and the people who are like intermediate people or advanced beginners like me, and also like people who are super experienced, and also rest of the people like Ray. So it's so I think this is one of the biggest initial complaints about Clojure is this around the developer tooling and ecosystem, right? And that's because we all remember the days when we had to use Slime instead of any Clojure related stuff.
I don't remember those days. But
yeah. So that was good old days, and without even Lightning and being on the horizon.
I was using Slime and in Emacs on Windows.
Oh wow! Okay.
So you've come full circle. Yeah.
Yep.
Exactly. So, but with tools like the stuff that you're building, like Kondo and Babashka, and the whole supporting tools which are providing these tools, these are helping like significantly everybody. So thanks a lot for that. And I don't think there is anybody who in the Clojure development doesn't use your tools anymore. But as I said, I mean, if you're not, then I hope you already paused and then installed it when we said that you are supposed to. So if not, go ahead and do it now. Thanks again, Michiel. It's a pleasure to have you on the show again, and hopefully we'll have you back again for the third appearance.
I'm happy to come back anytime, and thanks for inviting me. It's really great. Thanks for all the compliments.
Well, I'd say your brain is extremely fecund.
What the fuck does it even mean?
It means it's like a fertile place. Yeah.
Okay.
So I just thought I'd put that in there. It sounds very rude, but actually it's very nice.
Well, thank you, Ray. Your brain is fucking too.
Boom. So thanks, Michiel. It's always a pleasure. I mean, I think you're such a great developer and such a great bloke. So yeah, thanks very much.
Likewise.
Thank you. So that's it from us for episode number 69-1, and hopefully we'll see you in the episode 69-0 soon in a few weeks. Enjoy. Thank you for listening to this episode of DefN. And the awesome vegetarian music or the track is Melon Hamburger by Pizzeri. And the show's audio is mixed by Wouter Dullert. I'm pretty sure I butchered his name. Maybe you should insert your own name here, Dullert. If you'd like to support us, please do check out our Patreon page, and you can show your appreciation to all the hard work or the lack of hard work that we're doing. And you can also catch up with either Ray, with me, for some unexplainable reason. You want to interact with us, then do check us out on Slack, Clojurian Slack or Clojureverse, or on Zulip, or just at us at DefN Podcast on Twitter. Enjoy your day, and see you in the next episode. We just click record and then start talking, and then okay. If it is bullshit, it is bullshit.